Welcome all to this webinar on using Python for worksheet calculations. My name is Ishwar. Okay, so let's get started. I am using Origin version 2021, which was released late October, just a few weeks ago. So for you to try the features I am demonstrating today, you will need Origin 2021. If you do not have 2021, you may download a trial version and try. So before we get started with details on Python programming, I just wanted to give an overview of programming in Origin in general. So in this schematic on the right side, this is what ships with Origin. So as you may know already, Origin has a scripting language called LabTalk. It's a proprietary language that has been around since pretty much version 1 of Origin. So it's been around for 25 plus years. We have several users who use this still for performing customized analysis and graphing tasks and automation and such. Tech support often sends scripts to users for performing targeted tasks as well. Many versions ago, around version 8, we introduced Origin C, which is ANSYS C-based programming language built into Origin. And it has C++, C# features as well. And one of the benefits of Origin C at that point onwards was that we could tap into external libraries, such as the NAG library. So if you are familiar with statistics in Origin, ANOVA, multivariate analysis, hypothesis testing, non-parametric and parametric tests, all those are implemented using the NAG library routines, and several other features such as wavelet and such. A few versions ago, we decided to embed Python in Origin. What that means is when Origin is installed, Python is automatically installed for you. You do not need to install anything outside of Origin. We call that embedded Python. And as you may be familiar with Python already, one of the key benefits of Python is that you can find a package for pretty much anything nowadays. So once you have Python code access, you can tap into packages for enhanced data analysis and data transforms and calculations and such. Okay. In this recently published version 2021, we significantly enhanced this embedded Python. Large improvements have been made. I'll list them in the next slide. So this is why we decided to do a webinar focused on embedded Python today. My focus will be on this embedded Python. Just note, you can also access Origin from external applications using what is called automation server or COM program. So for example, client applications such as LabVIEW, MATLAB, Visual Basic, etc., could launch Origin as a server application and communicate data and send commands and such. Even external Python can be used in that manner. So if you have Python already installed on your PC, you could launch that with your favorite IDE and then write code there to talk to Origin. This external Python also has been significantly improved in 2021. But today's focus is on embedded. I'm going to just stay within Origin. Okay? Any questions, please feel free to type. If I'm speaking too fast, feel free to stop, slow me down. You can put comments in the chat window as well. Okay? So what are the improvements in embedded Python in 2021? I've listed them here. So most important is we introduced a package for Origin called OriginPro. The name is a bit misleading. Although the Python package is called OriginPro, it's available for both standard Origin and Pro Origin. This package allows you to communicate with Origin and control Origin, send data, change properties of objects in Origin and such. I'll show you the documentation in a minute. We also have improved our code builder to be a Python IDE, including IntelliSense and debugging, which was sorely missing in previous versions. So that makes it much easier now to prototype your code and create Python functions and such. And we also introduced GUI as well as script commands for handling Python packages. This was very awkward in previous versions. So now we have a nice interface I'll show you later for installing packages, updating packages, uninstall and such. A couple of other key improvements is that you can now create Python functions, and I'll be showing you examples of that today. And then you can call them immediately from column formula. You can also use Python functions in other places such as fitting. You can call Python code from text objects. And you can also access Python functions from anywhere that laptop scripting is allowed in Origin, as well as from Origin C. Today, I will mostly focus on column formula for the larger part of the presentation. Okay. So let's take a quick look at the documentation. So if you go to OriginLab.com, our main website, you can simply in the browser type /doc to go to the documentation area, OriginLab.com/doc. Okay, there are other ways to get to it, but if you remember this, you can simply type there. You can also get to it from the support center, from the help center and such. So here are all the online books for Origin Help. And one of the books is Python. So if I click on Python, as I mentioned to you earlier, you can access Origin as a server application from external Python. If you're interested, you could take a look at the documentation there. My focus is on embedded Python. So let me click on that. So we have written new documentation in this version for embedded Python. We have revamped everything. So you might want to go through this to take a look at how the embedded Python is programmed later after you watch this webinar to go back and find out more details. Okay. So here there are several examples, including how to even create a nonlinear fitting function using Python. I'm not going to get into that in this session. Also calling Python functions from Origin C. I'm not going to get into that either. I mentioned the OriginPro package. So there is extensive documentation on the package as well. I'll be showing you examples with this package. So here everything is outlined, the class hierarchy, the class members, the package functions, everything is available here for you to look at. Also, IntelliSense is supported. So when you code in Code Builder, you can, IntelliSense will pop up. I'll show that to you as we go along. Okay? So just mainly wanted to show you where the documentation is located. Okay. All right. So let's get started with some very simple examples. Okay. Just to get an idea of how the embedded Python works. And from there, go on to learn how to define a function, call the function from the set column values and such. So here I have some data in column 1, and I just want to sort it. Obviously, Origin has menus and functions for sorting, but I'm using Python just to illustrate how to do it. So I have a piece of code here, Python code. So if you have a few lines of code, you could run the code from the Python console. So in Origin now, there is a connectivity menu, has been around before. You have MATLAB console there, R console, mathematical link and such. And now we have a section here all for Python. Okay. So the first entry here is Python console. So let me launch that. So that opens the console. The first thing you will note is that it immediately tells you what version of Python we have embedded with Origin. It's 3.8.3. When the next version of Origin comes around, which will be in April, we may update it to whatever is the current established version of Python at that point. So here I can start typing my Python commands. So first let me type import OriginPro as, recall what I said earlier, OriginPro is the key package to allow communication between Python and Origin. Once I import that, I can start defining Origin objects. So for example, here I have an active worksheet. I want to talk to this worksheet and get data from it and put data into it. So I can say WKS equal to OP dot find sheet. So find sheet is one of the methods. And if I do not pass any parameter to it, I could pass a book name, for example. But if I don't pass any parameter to it, it will assume that my sheet is active. So I'm going to just use that. Okay. Now, if I just type WKS here, it will show you I have a valid Python variable, okay, which is pointing to book 1A, sheet 1. Okay. Now I want to grab the data from the first column. So I can say data into a list in Python. So I can say data equals WKS dot to list. So that means get data from Origin worksheet into a Python list variable. And then you need to give a column index. Python indexing starts from 0. So column 1 is index 0. So if I do that, the data will come into the data list named data. So there it is in Python. Then I can use a Python command to sort my data. Okay. If I type data again, you will see that the list is sorted. Now let me put it back. So then I use the method wks.from list. So fill the worksheet from a Python list, fill column number, second column, which is index 1, and the name of the list is data. If I do that, the data list that we created in Python and sorted gets put into the worksheet. Okay. So maybe very trivial, but a very gentle, simple introduction to give you a quick idea of how the OriginPro package works and how you can exchange data between the worksheet, Origin objects such as worksheet and Python. Okay. All right. Now, so if you are going to type just a few lines of commands, but what if we have many lines? So then the next step would be to put the code into a file. Okay. So let me take a more practical example. Here I have a signal with noise, and I want to smooth the signal using a Savitsky-Golay filter available in the SciPy package, Python package. Again, it has noise filtering, but I'm taking a simple example to illustrate how to use Python to do it instead. Okay. So I have here, I'll explain what it does. First, copy it. Okay, once I copy, I can go to the connectivity menu and open what is called untitled.py. Okay, if you do this in your Origin, you will see an empty file. I was practicing this webinar before, so I have pasted this code there already. Okay, let me go ahead and just paste again. Okay, so here's my code. Okay, so you can see that the first line is again import Origin so that I can communicate with the worksheet. Then I have a couple of other packages that I need in this code, NumPy and SciPy. Now you see, now that in Code Builder, which is the IDE for Origin, you will see already there is IntelliSense. So if I just place my cursor somewhere, you can see IntelliSense kicks in. So for example, let me just type this command again, WKS equals OP dot. And if I just wait, it will show me everything that's available, right? So then I can say OP dot find. If I start typing find, then it gives me these three methods: find book, find graph, find sheet. So if I choose find sheet, then I can start putting in my arguments. And in this case, again, with active sheet, I don't need an argument. So you can see that IntelliSense is built in into Code Builder. Okay. Coming back to Code Builder, let me now show you debug so I can step through this code and show you how it runs. So if I place my cursor anywhere that I want to add a breakpoint, There are shortcut keys. You can look at Code Builder documentation. F9 is for adding a breakpoint. So I have added a breakpoint there. Okay, so now I'm going to run through this code step by step. Okay, let me just move it a little bit over here. Okay, so for doing that, I can simply press the F5 key. F5 will the code, and because I have a breakpoint, it's stopping at the first line. Okay, then Code Builder has toolbars for stepping into the code, stepping over code, and such, and any things that you would expect in a standard IDE. So let me click Step Over. OriginPro was actually imported before. NumPy is now imported. SciPy is imported. Now WKS equal to op.findSheet. Okay. Now raw data equals WKS.toList1. So grab index 1, which is the second column, and put it into a variable into a data list called raw data. So let me execute that, and then let me show you we have variables window. So in the variables window, all the variables are listed. So you can go and see there is raw data right there. So it has grabbed the data. The next line is to smooth. So if I step over that line, I'll get the data smoothed into a new list called smoothed. You can see the list here. And the last command here is to put it back into the worksheet. So if I execute that command by stepping over, the smooth data comes back to the worksheet. Okay, so you can see I ran this code by smoothing. Of course, I can breakpoint. So let me go here and remove the breakpoint. And let me change some parameters here. I'm going to make this 101 points. This particular method, Savitsky Golay filter in the signal module in SciPy requires two parameters. One is the number of points, and the second is the order of the polynomial. So I just change the code, and then I can press F5 to run again. Okay, pressing F5, you see that the signal is a little bit smoother because I used a larger window. Okay, so that's the idea of running the code. But this is in an untitled file. What if I want to save it and later call upon that file? So you can simply go to File, Save As, and give it a name. Let me call it Smooth. I had already saved it before. I'm just going to save over the same file. Okay. So I have saved it. I can close Code Builder now. So I have a file called smooth.py. And let me show you how to call upon that file. I'm going to clear this column. So I have an empty column to receive the result again. And then I can go to the Windows script window. And now this is laptop. Origin can accept script commands in many places. We have tutorials on that. We have extensive documentation on that. So there is a command to run a Python file. So the command is run command -pyf, which stands for Python file, an external file, and then the name smooth.py. Okay, run -pyf smooth.py. So this is a laptop command telling Origin to go find the file smooth.py in my user files folder area, which is where by default the file is saved. I could give it a full path as well if I need to. You can look at the documentation for that. And then I just hit enter and the code is run. All the code in that file is run, and you can see that the output was created. Okay. So far we have seen how to write a piece of Python code, run it from the console, run it from Code Builder with debugging and IntelliSense to develop the code, save it to a file, and run the file. Okay. Any questions? Feel free to type questions, please. Okay. I'm not going too fast. Now let's see how I can take that piece of code that I showed you and convert it into a function. Okay. You may not always want to keep code in a file and run the file. You may want to define a function, and there are benefits to doing that. And I'll show you why. Okay. through this example. So let me go here and let me just zoom in a bit so you can read the code a little better. This is the code that I had just ran from the file. It's using NumPy and SciPy and using the Savitsky-Golay filter in SciPy signal to do the smoothing. That same code can be written as a function. I'm assuming you have some familiarity with defining functions in Python. But anyways, let me explain. So outside of the function, there are two lines, which are again to import the packages that are needed. NumPy as NP from SciPy import signal. Okay. Then here's the definition. As you know, this is the standard syntax for defining a function in Python. Okay, and the function body has to be intended by a tab. Okay, as you know, Python is very sensitive to spacing. Okay, so here I have given it a name smooth, and y is my input, which is a list of floats, real numbers. And then it requires two integer parameters. One is the number of points, and the other is the order. In the previous example, I had just hard coded it, if you noticed. Now I'm making it a variable. So there are three variables here, a float and two integers. When you define a function, one way to declare functions in Python is to use docstring. This is not unique to Origin. It's just a Python way of defining functions. So what this docstring is saying is that there are three inputs to the function: float, integer, integer. And then it returns float. So that's what this syntax means, f colon fii. Okay. So this part defines the input and output types. Then here's a function. Y equal to signal.savGoal filter. The list needs to be converted to an NP array. That's why we had the NumPy in there. And the number of points and order are passed, and y is returned, and this function then returns y. Okay, so this is the function definition. So essentially all that this code did, we have converted that to a function. So let's copy this and see where to define it and how to call it. Okay. So I have again the same data, but this time I'm going to use a function. Okay. So from the connectivity menu, let me open this entry called Open Default Python Functions. Okay. That menu opens Code Builder with a specific file called laptop.py. And the understanding is that any function you define in laptop.py, this file is shipped with Origin, and by default it has only one function in there. I had already pasted this function while I was practicing for the webinar. Okay, so I have put my function in here. So as you notice, here is my definition, and here are the packages required for the function that are right above the definition. Okay. Once I have defined my function in laptop.py, I simply save that file. Now this function is immediately accessible in Origin. Okay. Let me show you how to run it. So here I have column B with the raw data, and I want column C to be calculated using that function. So I can simply right click and choose set column values. You may have used the set column value dialog many times in Origin. Origin comes with over 500, 300 to, I lost count, over 300 functions in many different categories. These are all built-in functions. But now the beauty in 2021 is you can create your own Python functions and use them. So we have just defined the function, how to call it. Remember, the function required three inputs. So the way to call it is I say py.smooth. Okay, that tells Origin this particular function called smooth is a Python function. I don't have to say where it is located because by default it will look in laptop.py. Okay, that's the default location for function definition. Then I can put in my parameters. Remember, the first one was a list of floats. That's my column B. Then window 101. Third one was the order 3. Okay, so now if I click apply, that function will be called and the data was processed and you see the result here. Okay, hope that was clear. So here the function was defined and still defined in a file, not just code saved in a file, a function defined in a file, and then I was able to use that function immediately. Okay, let's take it one step further. I'm going to copy this function again, Control C, and this time I'm going to define it right in the worksheet. Okay, so I'm going to right click here and bring up set column values. And you notice in the bottom panel here, there is a before formula script. This has been around in previous versions of Origin. Here you can put laptop script, but what I have is Python code. So we have a tab called Python function. Here you can define your function in local scope right here. Okay, let me simply change the name so that I don't necessarily conflict with the other function. Also, you can see it is indeed calling the function I'm defining here. So I called it mySmooth. Okay, again, the same definition. And up here, I say py.mysmooth. So Origin will first look locally to see in the local scope, is there a function? If not, then it will look in laptop. Okay, so let me put in a different number of points for the window, a really large window, and then click apply. Okay, name signal is not defined. Oh, okay. Sorry, I forgot to copy the necessary modules. I should copy all of these lines. Control C, back here, and redefine my function. Okay, and then click apply. Okay, where did that fail? Let's see. Functions, numpy, scipy, call it mysmooth, and here mysmooth b, 101, 3. Okay, so it's calling the function mysmooth. I probably had a typo in the previous one, or because I ran it one improperly without the plugin, so that's why I got a broken lock. Okay, I can simply turn on the spark lines again. In recent versions of Origin, we have these mini toolbars. When you click on objects, contextual toolbars pop up, so I can immediately use those without having to go to the menu. So you can see here. By the way, whatever I typed, you can see it shows up in the. So just to explain that, let me open set column values again. This is a formula. The formula can be anything. A simple function from the function dropdown. In my case, it's a call to a Python function. So that's what you see here. You do not see this part of the script in this line. So this line is just a formula box. And here is my Python function definition. Okay. So why did I define the function in the column itself? The benefit with that is now I can save this book as a template. Okay, so I can go File, Save Template As, and I can give this some name called mysmooth. Okay, and then the benefit of saving it that way is later I can open that particular template, and then in that instance of the template, okay, new from template. Okay, so let me see. Where is my workbook template go? Create Excel table. User files folder. That's where my templates would be, mysmooth.otwu. So if I open that, you see, if I click here and open my set column values, everything is there. The function definition is there. The formula is there. So now you can use this in any project anywhere, or you can even send it to a colleague. You can say, hey, I wrote this, created this nice template that uses Python, yada, yada calculation. Here you go. you can give it to your colleague and they can benefit from it too. Okay? Questions? Now, let me show you under the connectivity menu another entry called openexamples.py. I would strongly recommend that you go through this file. What we have done here is to ship Origin with several examples, which gives you an idea on how to define functions and what is the syntax to use. I earlier used docstring, but you can also on the fly define the types right here. For example, this is a simple sort function. It takes list as input and returns a list. Okay, that's another way. You can take a float and an integer and return a float. Okay, so this file has many such examples and it lists all of the docstring types as well that we support. So you can look through the functions here, copy any that you like, bring them into laptalk.py, and then they become immediately available for you. Okay. Let me walk through another example now to show you the flexibility of defining functions inside the sheet itself. Okay. For that, I'm going to show you an example where I have some data here that's categorical. I have seg1, 2, 3 in column 1. I have some x and y values. I want to find the mean of x and the mean of y for each of these categories. And I want to do that using Python. Okay. So let me go to File, New, Workbook. Okay. This opens a dialog called New Workbook. Has been around in Origin before. In this version, we have added many Python examples. Okay. If you hover, you will see. Here's a Python example. Here's one on ARIMA. Okay. Many others. Gradient booster. So let me open the stats by grouping column example. Okay, that's a template that we ship. So you'll see that this template is, of course, empty. It's waiting for data. There are 3 columns here that are the output. They have logs on them. Let me first copy the data, the raw data that I have here, put it into this template, and then explain what the function does. When I paste, the function immediately runs. Okay, you can see that it computed the mean for each category, seg 1, 2, and 3, broke up the subgroups and computed the mean x and mean y. Let me click on this green lock and do change parameters to open the set column values. You will notice a few things. There is no formula here because this function takes 3 columns and returns 3 columns. So I cannot use a single column as a formula. The beauty in Origin is that that's supported too. So if you in this before formula script, it in column DEF equal to some function of column ABC. So I can pass multiple columns to a Python function and have it return multiple columns as output. Okay? So this is LabTalk. Okay, this is in the before formula script that used to exist before. Now let's look at the Python function tab. So here is the key function, the Python function, group stats. Okay, and you will notice here a docstring is used. It has a label and 2 floats as input because the first column is string. Okay, and it returns a tuple. Okay, and then this particular function uses the pandas package. So that's why there is an import pandas up here. Okay. And this is where the flexibility comes in of Origin being able to communicate with Python back and forth. We have capability to grab a whole data frame. Okay. And create data frames and manipulate that and put that into the sheet. Okay. So for example, here, it's grabbing the data, creating a data frame using the ID and the X, and then it's using this group by method of the data frame, and then it's returning the data frame's index, data frame's mean for X and mean for Y. Okay, and that's how 3 things get returned and 3 things get populated in the worksheet as the result. Okay, so it's pretty powerful being able to use data frames to manipulate data in the entire worksheet. and return multiple columns or return another sheet and such. Okay. Any questions so far? So far, everyone's so quiet. If you have any comments, please put in the chat. If you have technical questions, put in the Q&A window. Okay. So I think personally that being able to define functions quickly and use them for calculations is a pretty nifty feature in Origin using Python. So that's what my main focus was today was. But let me still show you some other examples of running code from other places. Okay. So I already showed you how to run from console, how to run from a file. Now I'm going to show you an example of how to place code in a text object and run it. Okay. So for this purpose, I'm going to open a couple of examples from the new workbook area and walk through them. Okay, the first one is Lom's-Cargill periodogram. Let me go File, New, Workbook. And here, one of the examples is Lom's-Cargill periodogram. So let me click and open. So this is a template that we ship with Origin 2021. So Origin has FFT, but it doesn't do FFT for time data that is unevenly spaced. But for that, there is Python code available, particularly a method called Lom's-Cargill periodogram to compute the power spectrum. Okay, so here in this example, here's my raw data, my X and Y, my time and signal. Here are two columns that are set up to receive the output, and this graph will show whatever data goes into the output. And I have two objects here, a button and a text object. Okay, let me right click on the text object and look at properties. Okay, and if you look at properties, there is a programming tab, and you will see in the programming tab, there is the Python code. Import OriginPro as OP, import NumPy, import SciPy, because SciPy has the Lom's-Cargill periodogram function. Okay, and then here is the code. Okay, this is not written as function, it's just code, Python code. So this is similar to the first example I showed you. I just write some code. I'm assuming it's the active sheet. I'm grabbing data directly from the sheet and such, not passing to a function. Note that this has a programming name called PyCode. Okay, so the code is housed here, but the code is actually called from this button. You can take a text object, place it in worksheets and graphs, and make it into a button in Origin. Okay, you can look up the documentation for that. To see what's behind the button, I just hold the Alt key and double click. Okay, so what this has is under the programming tab. It's also a text object, but it has set the script run property to button up. That's why it became a button. Okay, in this code, the first line is a script command, pip-check SciPy pandas. Because this particular example requires SciPy and pandas package, there is a way in Origin to automatically check, does the user have it? If not, it will prompt a message saying these packages need to be installed, and user clicks yes, and they will get installed. Once that's available, the next line is run-pyb PyCode. So that's basically saying run the code saved in a button or text object named PyCode. So it's essentially, this button is asking to run the Python code saved in that object. So if I click OK and then click this button, it's going to run the code, and there is my periodogram. Okay. So this is another way to create templates without using set column values, but embed the code as part of the template itself in a text object. Let me show you one more cool example. So I'm going to go open that workbook tool again, dialog again, and this time I'm going to choose the regression clustering example. So this is an advanced machine learning kind of example where I have some data, some points that sort of overlap, and I want to do clustering to mark which data point falls to which cluster. One would be a cluster going this way, and there would be a cluster going that way. So if I again right click on this and choose properties and look at programming, you will see the Python code. It's using scikit-learn package, okay? And there is something called ridge regression, which is used to do the cluster-based regression. I'm not going to go into the details of the code, just showing you another example of housing the code as part of the template and then running it. So when I run, it shows all these red points as one cluster and shows all the black points as another cluster. Okay. So the sky is the limit, really. There are so many Python modules out there to tap into and bring that power into Origin for performing data processing and analysis. Okay. Let me finish with a couple more examples. Where at the beginning I showed you that you can write Python code in Code Builder and save it in an external file and then run it. But rather than saving in an external file, you can also save it as part of the project. Okay. Let me show you an example of that. This time I'm going to press the F11 key, which opens the Learning Center in Origin. You may already be familiar with this. This is a good place to come to for any version. So for example, if I choose the graph samples here and type 2021 as the keyword, click search, it will show me all the graph types that have been introduced in 2021. These nice looking categorical special charts, which are available for you to play with, chord diagrams, and then lollipop plot. We also have polar vector, a stacked browser plot, and such. Okay. Now, if I switch to analysis samples, there are several categories here. If you can come here, it's worth looking at the curve fitting examples and such. We also added a Python category in 2021. There are many examples here. I'm going to choose the last one here, traveling salesperson problem, and click OK. Now it's going to open a project, okay, an entire project. It's asking me, do I want to save this current project? I said yes, and then it opened this project. Now, this project, let me quickly explain. It's the classic problem of minimizing travel between cities, okay? So here I have a sheet with about 2,600 airports. And in the second sheet, I'm randomly selecting 10 airports using a Python code, using data frame. And then I will run a code to optimize the travel so that the distance traveled is minimized. Okay. So let me first click and show what happens. If I click the optimize button, it's going to run the optimization code and it optimizes the path. Pick another 10 random airports, optimize. Okay. Pick random again, optimize. Okay. Now let's look at the code. Now if I go to Code Builder, okay, and look in the left side, you will see one of the branches is project branch. What this means is that the project can have attachments. You can put any file as attached to the project. You can attach a Word document, a PDF, notes, whatever you want to save with your project and give it to your colleague or for your archiving purposes as well. So here I have attached two files, randompic.py. My colleague James Chen developed this example, by the way. So here he is using data frame, and then he is using a cool method of sampling to get 10 random samples, which is what the first button was doing. So the first button is calling randompic.py. The second button is calling tspoptimize.py, which is where the scikit-learn package is used to do the optimization. From scikit, it's importing a certain method for the traveling salesperson minimization. It has a built-in method for that, and then passing the data to that and doing iterations and getting the result. Okay. So if I come back to Origin and Alt double click on this button, you will see that's what it's doing. It's calling run-pyp randompic.py. And if I Alt double click here, it's calling tspoptimize.py, the other file that was attached. So I hope this was a good illustration as well. Let me go back to the original project. Okay. So today in the webinar, we covered the basics of writing Python code, using the OriginPro package, running the Python code from several places, such as from the console, from an outside file, defining a function, and even including the function in set column values, and then saving it as a template, running Python code from text objects, running code attached to the project. So there are several ways to run Python code. You may pick and choose what works best for your particular situation. Last but not the least, I also wanted to show you under the connectivity menu, we have a Python packages tool. So this tool lets you install any Python package. So if we send you a particular solution, we may automatically code something in the solution to auto install the package. But if you are developing some Python code and a package is needed, you could simply come here and click the install button and your Python package. I'm not going to do it now because some packages take time to download. All this is documented. You can type in your Python packages space with space separation, multiple package names, and Origin will get all the packages that are compatible with the internal embedded Python version and install them for you. And you can also do upgrading and such. Note that one of the packages, it's OriginPro itself. So the package that we use for communicating between Python and Origin itself is a package that we can keep updating. So we already have it up to version 1.0.1. So anytime you can click upgrade to get the latest OriginPro package as we make improvements to it during the span between releases. Okay. There are several resources. There are ways for installing package from the script as well. I'm not going to go into the details of that. If you are into laptop scripting, you can look up the documentation. I'm going to leave you with a link to many of the resources for Python. I'll open some of them and show you. One of them is our blog, blog.originlab.com. We have a Python category. Here we have already many samples, accessing Origin's graphing power from Python, many blogs already written, how to use it in import, how to use it for curve fitting, summation fitting using worksheet template using Python, several examples here, okay? These blogs are very technical and you would like them. Documentation I already showed, everything is documented here, all the embedded Python. If you hover here, you will see all of the different subtopics here, okay? Several code examples as well. Outside of what's installed in Origin, there are many, many code examples here using data frame, splitting data sets, metrics manipulation, many things, even examples such as using OpenCV to load TIFF files, okay? Then I showed you the templates that are built into Origin. I showed you the F11 dialog. There are some projects under samples Python folder in installation as well. There's also a Python forum. If you go to the Origin forum, you will see there is a special sub forum on Python. So you could go there and post questions there as well. Last but not the least, we have our wonderful tech support staff who would be happy to help you if you approach them with your questions on Python. So I hope this webinar was useful. Quite a bit was covered. At this point, I request your feedback. Please take a few moments to answer the poll questions. This helps us in making our webinars better and also deciding new topics for the future. Let me quickly show you where to go for getting the recording next week. So if you go to originlab.com and if you click on support, there is an entry for webinars. So if you click on that, it takes you to the main webinar page. We haven't put up the webinars for December yet. So we have 2 webinars coming up next week on curve fitting basics and user-defined fitting functions. And then below here, you can click to find recordings of all of our past webinars. We have put in many recordings here. You can play them right on our website, or you can go to YouTube and play. The benefit of going to YouTube is that we also have timestamps there. So you can click on the timestamps to jump to a particular point in the webinar. So you don't have to play and wait to get to the favorite section that you're looking for. Okay. All the timestamps have been added here. thanks to my colleague, Jennifer Sweck. Okay. So hope this was helpful. You will get the recording, you will get the project, and we look forward to your feedback and look forward to seeing you in a future webinar. I'll leave the Q&A and chat open. If you have questions, you can still type them. Thank you for attending today and have a wonderful rest of the day and be safe out there. Thank you.